We're going to be talking about capacity in this module. Capacity is what is our throughput? What can we put through our organization? And this can be a number of different things. Our finished product, what kind of product can we put through? How many employee hours do we have capacity for? How many seats can we fill on an airline? How many seats can we fill in a stadium, etc.? Those are good capacity measures. Capacity decisions occur over 3 time horizons. First, we have our short-range planning. What jobs do we need to complete? What do we need to produce today? What do we need to produce next month? What staff do we need? How many employees should I have? How many employees on each shift should I have? What machinery is needed? And what hours will the plant run, etc. Next, we move on to our intermediate range planning, the aggregate planning. So short-term planning is more often referred to as scheduling. Makes sense, right? Scheduling the hours, scheduling the plant, production. Intermediate is going to ask how many shifts should we have? How many should our plant operate based on our capacity, our demand, etc. Should we add machines? Should we reduce machines? Can we be more efficient with better technology? Should we outsource some of our production? Should we outsource some of our operations? Then we move into our long-range planning. What's the mission of the organization? Do we want to acquire additional facilities? How big do we want to be? Do we want to grow capacity? Do we want to grow production? Do we want to scale down operations? What are our plans? How does our existing capacity align with those long-range plans? Do we need new facilities? Do we need new production methods? Do we need a major expansion? Should we be looking at acquiring competition? Should we look at selling off divisions? How about abandoning product lines? Adding product lines? Offshoring? Those are some of the things we might consider in our long-range planning. So when we're looking at capacity, we're looking at design and effective capacity. Design capacity is sort of what was the operations designed for? What's the capacity that we designed our operations for? How much in a perfect world could we do? So design capacity is the maximum theoretical output of a system. It's normally expressed as a rate. Effective capacity, on the other hand, is the capacity a firm expects to achieve given current operating constraints. So things that we might have to have some maintenance days at our plant, so we might have to shut down a few days, those kinds of considerations. So here on your screen, we're looking at design capacity, ideal conditions that exist during the time that the system is available. So we're looking at Frito-Lay is designed to produce 1,000 bags of chips per hour, and the plant operates 16 hours a day. So 1,000 bags of chips an hour, operating 16 hours a day, they can produce 16,000 bags per day. Now let's take a look at how that changes when we look at our effective capacity. We have lost output because of planned resource unavailability. We've got some maintenance, some machine changeovers, changes in our product mix. We have to give our employees a break, etc. So now we take a look at what is our effective capacity. So we lose 3 hours of output per day, a half hour on preventative maintenance, an hour for employee breaks, and 1.5 hours setting up machines for different products. So now we're going to revise that capacity. Now we've got 16,000 bags per day minus 1,000 bags per hour, 3 hours a day. So 16,000 bags a day minus the 3,000 bags a day that we're unable to produce because our systems aren't operating equals an efficiency factor of 13,000 bags per day, effective capacity. Then we look at what's our actual output. So effective capacity minus lost output. So those are unplanned. We have employees that don't show up, machines that break down. We have unavailability of parts, supplies, input, whatever the case might be. So how are we operating in comparison to our effective capacity and to our design capacity? So let's say our actual output is running 1 hour a day due to late parts, so we've got another 1,000 bags per hour that we're losing, so we're only doing 12,000 bags per day. Remember, we had an effective capacity of 13,000 bags per day. So utilization is the percent of design capacity that we actually achieved. It's the actual output divided by the design capacity. So in this case, it would have been the 12,000 divided by 16,000. Remember, 16,000 was our design capacity, and our actual output was 12,000. Efficiency is the percent of effective capacity actually achieved. So efficiency is actual output divided by effective capacity. In this case, that would have been the 12,000 actual output divided by the 13,000 of effective capacity. Let's take a look at a productivity example. In this case, we have an effective capacity of 175,000 units. We have an actual output of 148,000 units, and we are operating 3 8-hour shifts 7 days per week. We can produce 1,200 units per hour. What is our design capacity? Our design capacity is our availability. So we have 3 shifts times 8 hours times 7 days per week times 1,200 units per hour. Our design capacity is 201,600. Now, if we're actually producing 148,000, what is our utility? How much are we producing of our design capacity? Here we're just simply going to take that actual output of 148,000 and divide it by the design capacity of 201,600, and we get 73.41%. So we're utilizing 73.41% of our total capacity. What is our efficiency capacity when we're allowing for time to change over, repair parts, normal maintenance, employee breaks, etc.? So our efficiency capacity is going to be the actual output of 148,000 divided by the effective capacity of 175,000. Our efficiency capacity is 84.57%. Next, let's take a look at the question. So in case number 2, we want to know, we're looking at a decrease in demand for whatever reason. And so we're considering dropping one of the shifts. What happens if we do that? So let's look at dropping a shift. So the effective capacity and the actual output, we won't need that information. We don't really know what those are with dropping a shift. So now we're going to say we're going to have 2 shifts, 8 hours, 8 hours per shift, 7 days per week with the 1,200 units. And our formula will be the same. So we can probably just copy that over, and we get a new capacity of 134,400. So we're looking at, we had an actual output of 148,000. We're expecting a decrease in demand. Is this going down too much? That's an unknown, and we'd be operating pretty close to that probably effective capacity. Now let's take a look at number 3. Asks us, another option would be to maintain 3 shifts but only work on the weekdays. So now instead of, we're going to have the 3 shifts, let's just copy this all over. But now we're working 5 days a week instead of 7. Now what happens to our capacity? Now our capacity went from 201,600 to 144,000. So that seems like maybe a closer number to be to if we're expecting a decrease in demand. And it looks like it'd be a little safer than number 2, going to keeping the 3 shifts and 5 days a week. But this is really an unknown because we don't know what that expected percentage decrease in demand looks like. Next, we're going to take a look at a company that is doing a forecast for the next 5 years and trying to anticipate the number of machines that they should have, a little bit of an intermediate to long-range planning. The manufacturer currently has 4 machines that operate 2 8-hour shifts per day. They take 10 days for maintenance, running 5 days a week, 52 weeks a year, minus those 10 days. Each manufacturing good takes 120 minutes to produce. So A, we're asked, what is the capacity of the factory in units? I'm just going to add some rows here. So what is the capacity of the factory in units? We're looking at the manufacturer currently has 4 machines, 8 hours per day, 5 days a week, 52 weeks a year, and it takes 120 minutes to produce. So our measurable that we're looking for here is machine hours. That's kind of the only information that we're given. So what we're going to do is we're going to come up with how many machine hours do we have available and how many machine hours does it take to produce a good? How many machine hours are needed? So our capacity is going to be machine hours divided by the production hours needed. How do we get our machine hours? Well, we're going to say we've got 52 weeks, right? So it equals 52 times 5. And then we have 10 days. So I'm first coming up with the number of days that we're operating. So we've got minus 10 days for maintenance, I believe. Oops, I did that backwards, didn't I? I don't know what I did there, excuse me. So those are the number of days that we're operating, and we have 2 shifts and 8 hours per shift and 4 machines. So our number of machine hours available is 16,000 machine hours. And we also know that each manufacturing good takes 120 minutes to produce. So we've got machine hours here of 16,000, 120 minutes to produce. How many hours is that? That's 2 hours. So what is our capacity? 16,000 machine hours divided by 2 machine hours needed per product equals a capacity of 8,000 units. So now we're asked to calculate the capacity for each year. So the first one's sort of easy, right? So we've got capacity is 8,000 divided by 8,000. It's our 8,000 units divided by, excuse me, that should be going the other way around, right? It should be the forecast demand divided by our capacity number that we arrived at in A. So that's 100%. Let's change these to percentages. And if we'd done the F4 absolute cell reference there, that would have worked a little better. Okay, we can see that we've got some pretty good capacity excess, not enough capacity, excuse me. We're exceeding capacity in years 2, 3, 4, and 5. We're at complete capacity in year 1. So the next question asks us, does the firm need to buy more machines? And if so, how many? And when? If not, why not? So what we're going to do here is there's a few different ways that we could solve this. So I'm going to take a look at what is my average capacity here. So let's just do equals average. My average capacity is 122%. So my excess machine hours that are needed would be, could we agree that we currently have 16,000 machine hours? That would be 100%. So 122%, our excess over the average is the additional 22% that we need. So we're going to say equals 16,000 times 0.22, 22%. So we need 3,520 machine hours. How many machines should that be? So there we're going to take our excess machine hours needed, and we're going to divide that by the hours of operation again. So that was the 52 times 5 minus 10 times 2 times 8. 2 shifts, 52 days times 5 days per week minus the 10 days and 2 shifts of 8 hours. So we get